Hello everyone, I am Ahmet Furkan Kocabaş from Mechanical Engineering Department at Abdullah Gül University. Today I will show you how to solve 3D equilibrium questions by using MATLAB, software MATLAB. So let's get started. Let's read the question at first. The shear leg derrick is used to haul the 200 kilogram net of fish onto the dock. Determine the compressive force in each of the legs, AB and CB, and the tension in cable DB. Assume the force in each leg acts on its axis. So in the question, it's given that AB and the CB are under compression, DB is under tension. So let's start with showing the direction of all forces. For AB, it should be like this because it's under compression. It should be pointing this point, B. Same for CB. But for DB, it should be something like this because it's under compression. It should be toward to point D. So next step, we need to know coordinates of these points so that we can calculate position vectors. Then after that, we can calculate unit vectors, right? So let's write the equations. For example, for force AB is equal to magnitude times unit vector AB, right? Same for other forces. So let's start with the finding out points and their coordinates. So for that, I open a new script and I will define now the points. For example, point A is, as you see here, it is 2, 0, 0, 2, 0, 0. Point B is equal to 0, 4, 4, 0, 4, 4. Point C is equal to minus 2, 0, 0, 0, 0. And the last one, point D, is equal to 0, minus 5.6, and 0, 0, minus 5.6, 0. We have defined the points. Now we are ready to define also position vectors for each force, right? So let's recall position vector AD is equal to point B minus point A. So let's say recall. Now let's start typing down the position vectors for each force. Let's start with force AB. So position vector AB is equal to B minus A. Position vector CB is equal to B minus C. Yep. Position vector BD is equal to, yes, it's B, from B to D. So we need to write D minus B. Yeah, we have defined position vectors. Further, we also need to find unit vectors of each forces so that we can calculate magnitude of them. So we know that for any force, unit vector is equal to position vector. Let me make this position vector over magnitude of position vector, magnitude of position vector. So basically, we need to divide position vectors by their magnitude. So let's start. RAB, unit vector AB is equal to RAB over, we need to find its magnitude. For this reason, I want to use a specific function to calculate the magnitude, which is called norm function. If you use norm function, you need to plug in the vector that you're trying to find its magnitude. So that's it. Here, actually, it's magnitude of RAB. So let's continue with the unit vector CB, which is equal to RCB over norm RCB, and same for BD is equal to RBD over norm RBD. Yeah, let's run the code until here. So yeah, we have defined position vectors. By using position vectors, you're able to define unit vectors. Now, this is, let me write it this way. This is for FAB. This is for FCB. This is for FBD, right? So actually, we have three different, as you see here, we have three different unknowns, which are FAB, FCB, FBD. We are supposed to find them. We are supposed to calculate them. And also, we have three different equations, which are X, total Fx is 0, total Fy is 0, and the total Fz is equal to 0. So we need to write equations and solve them using MATLAB. Now I will show you how to do it. Now we have unit vectors. Unit vectors times FAB, actually its magnitude, will give us the vector form of FAB, and same for the others. For this reason, for example, first element of this vector is actually x component of vector FAB. Same for the others. For example, first element of UCB is the x component of FCB, vector FCB. And if you add them up, because this system is under equilibrium, they should be equal to 0. This is for x. Y, same. However, in the z direction, along z-axis, we have also a load. Let me write here. Load is equal to 200 times gravitational acceleration. Now, I need to write each equation and solve them. However, if you use MATLAB, you can do it easily, right? Let me show you. First of all, I want to take transpose of each vector. Yes, UCB is equal to UCB transpose, and UBD is equal to UBD transpose. Okay. After that, next step is equal to create another matrix whose columns are these vectors. Okay, so UCB, CB, UBD. Okay, now I need to write the other side of the equations. Along x-axis, there's no other force, so it should be 0. For y-axis, there's no other force, external force, so it's equal to 0. However, z-axis, along z-axis, we have an external force, which is equal to load. So I need to write load over here. After that, I will use this operation to calculate the forces FAB, FCB, and FBD in order. So let's run the code. Here you can see each forces and their magnitudes. For example, FAB is equal to 2.5, same for FCB, and for FBD, it's 3.6. This is how you can use MATLAB to calculate 3 equations, 3 unknown questions, which are actually from 3D equilibrium questions. Thanks for listening. I hope you enjoyed.